Good day, my audience. We are here again. We are still on systems of linear equation, but rather application now. We are applying systems of linear equation to linear combination of vectors. Now, assuming that the vectors you want to get their linear combination are orthogonal to each other. For instance, we have here on the board, write the vector v as a linear combination of u1, u2, and u3, where u1, u2, u3 are orthogonal. What do you do? First of all, remember that vectors are orthogonal if u1 is orthogonal. If u1 is orthogonal, I shall use this symbol for orthogonal. If u1 is orthogonal to u2, then we have u1, the dot product of u1 and u2 will give us 1 times 1 plus 1 times minus 3 plus 1 times 2 will give us 1 minus 3 plus 2, and that is 0. So their dot product will give us what? 0. If you also try the product of this and this, you have u2 being orthogonal to u3 will give us u2 dot u3 is, we have our u2 is 1 times 5 plus minus 3 times minus 1 plus 2 times what? Minus 4. This will give you 5 plus 3 minus 8, which is what? 0. If you also try the next one, the last one, u1 orthogonal to u3, you have u1 dot u3 will give you, u1 dot u3 will give you 1 times 5 is 5, 1 times minus 1 is minus 1, 1 times minus 4 is minus 4, and that will give you what? 0. 5 minus 5 is what? 0. So what trick are we going to use to solve, to write v as a linear combination of these vectors? Remember that if v is a linear combination of these, it can be written as v is equals to x u1 plus plus y u2 plus z what? u3. Okay? And then you can write them as, you still have what you have. You have there, the vectors are, you have 4, 14, and minus 9, x in brackets. You have your u1 is 1, 1, 1, plus y in brackets. Your u2 is 1, minus 3, and 2. Okay? Finally, you have z is equal to, okay, z in bracket 5, minus 1, and minus 4. Okay, right now, our work now is to find the value of x, y, z. I'm not going to solve it using the Gaussian elimination method. If we still solve it using the Gaussian elimination method, we will still arrive at the right answer. But I want to make it faster using the notion that if two vectors are orthogonal, if u1 and u2 are orthogonal, their product will give me what? Their dot product will give me what? 0. So if I multiply each vector by u1, okay? If I multiply each vector by u1, I will have 4, 14, minus 9, dot product of 1, 1, 1 is equals to, if you multiply, you have x, 1, 1, 1, dot 1, 1, 1. Then the dot product of u1 with u2 will give you 0. Remember from what we have here, u1, u2, their dot product will give you 0. So that means that we're going to have 0 here plus 0. Also, the dot product of u1 with u3 will also give you what? 0. So what we have here is the dot product here. We have 4 plus 14 minus 9 is going to give us x brackets 1 plus 1 plus 1. So this will give me 18 minus 9. 18 minus 9 is what? 9, which is 3 what? X. Therefore, x is equals to what? 3. Very, very simple in that way. So that makes it easier and simpler. Now, also, if we want to find our y, what do? I'm going to clean up this place because here is not really going to enter again. I'm going to clean here. We have gotten our x as 3. Okay, so I'm cleaning here, returning this. Now, if I multiply, rather this time, each vector by u2, I will have 4, 14 minus 9, dot product of u2, which is 1 minus 3, 2, is equals to, now, if I take the dot product of u2 with u1, here will become 0. And if I take the dot product of here with itself, it's not going to be 0. And then the dot product of u2 with u3 will also be what? 0. So we are left with 4 minus 42 minus 18 is equal to, okay, we have y brackets 1 plus 9 plus 4. This will give us, we have 60 here, minus 60, that is minus 56 is equals to 14y. So that y is equals to minus what? 56 divided by 14 is supposed to be 4. Okay? It's supposed to be minus 4. So our y is equals to minus 4. Now finally, if I multiply each vector, rather this time, if I multiply each vector this time by u3, each vector in that equation by u3, we're going to have the dot product 4, 14 minus 9. Take its dot product with that, 5 minus 1 minus 4 is equals to, now the dot product of u3 with u1 will give you 0. Dot product of u2 with u3 give you 0. And then you have z in brackets 5 minus 1 minus 4. 5 minus 1 minus 4. And then when we take the dot product here, we have 20 minus 14 plus 36 is equals to z brackets 25 plus 1 plus 16. Okay, so when we add this up together, we have 56 minus 14. 56 minus 14 will give us 42. We have 42 is equals to, let's add up here. This is 26 plus 16 give us 42. We have 42 what? Z. Therefore, our Z is equals to 1. So our Z is equals to 1. So we can write V. I can write V now. Okay, I'll come here now. I can now comfortably write V as a linear combination of this, where x is equal to what? 3, and our y is equals to what? Minus 4, and our z is equals to what? 1. Is